This question again appeared in 21 for 2 marks, and that is based on buck-boost converter here. And we had to calculate the average current flowing through the inductor. So in buck-boost converter, uh, average current through inductor will be equal to the load current plus source current. So you can see I have directed both the current, and IL is equal to I in average plus I naught average. And we are neither given with I in nor I naught. So we have to calculate. First, before calculating anything in any question in gate based on DC to DC converter, we have to check whether the converter in continuous conduction mode or discontinuous conduction mode. So I have did that, and you can verify it from the critical value of inductance. If the critical value of inductance is less than the inductance which is given in the problem, it would be continuous conduction mode, and we are going to do that. So for that, if the minimum value of inductor current would be more than zero, or if inductor current is never going to remain in zero state, then the converter is in continuous conduction mode. Now, this is the condition for critical conduction. It is just touching the zero axis, and again it is started rising. For continuous conduction, it is never going to touch zero. For discontinuous conduction mode, you can see it is in zero state for some time, and after that it is again going to charge. So these three are the conditions for conduction in DC to DC converter. Now, I have done from the expressions, if the minimum value of inductor current is greater than or equal to zero, then our converter will be in continuous conduction mode. Then IL average minus del IL by 2 would be equal to minimum value of inductor current here, and del IL you can calculate from the formula of VL dt, volt second balance, from 0 to dt, means conduction time, till conduction time. So from this formula or from this expression, you can calculate del IL is equal to dVs by FL. If you calculated del IL is equal to dVs by FL, everything is done here. So from here, L critical you can calculate, and that will come out to be 12.5 microhenry. So 12.5 microhenry is well below the given inductance value, that is 1 millihenry. And so this guarantee that this converter in continuous conduction mode, if it gives the condition, then I know V naught by Vs is nothing but the 60 volt, and V naught by Vs is 60 volt, then I naught is equal to 6 ampere and In is equal to 18 ampere. And we add both the current, then IL average is equal to 24 ampere. So the answer which was required, that will be 24 ampere here, and this was the answer. Thanks.